All right, now that we have learned a little bit about scatter plots and why we use them and how to interpret the picture of what's going on, now we're also going to talk about lines of fit. So today we'll talk about lines of good fit, and tomorrow we'll talk about lines of best fit. A line of good fit, we're going to do our best to approximate, but we're humans, so our lines might differ from each other a little bit. They're not perfect. So today we're going to talk about what a line of good fit looks like, and then tomorrow we'll talk about how a computer would make a line of best fit. So a line of fit in general, good or best, is a line drawn on a scatter plot close to most of the data points. So we're trying to use that line to model what's happening. So our points are kind of all over the place, and we want to use a line to model the data, but it's not going to fit every point perfectly. But it will help us make predictions with what's already happening and what we can see happening. And so right here, it can be used to estimate data on a graph. That's its purpose. The reason we want to draw a line of good fit or line of best fit, so that we can then take that equation and take the data we've gathered to make predictions about the future. So we're going to do a couple examples together today. So for this first one, we need to make the scatter plot before we can draw our line of good fit and make predictions potentially. So here, I am going to go ahead and label my axes. So remember, absences is X and final exam is Y. Their score more specifically, and yours is already labeled. Again, we're trying to make it a little bit easier on you by having it pre-labeled, but I still want you to know how to figure out the label if need be. So here, our absences, the smallest number we have is 0, so we'll start at 0, and then the largest we have is 9. Now, since this is 10 different grid lines, we'll just count by ones. So this would be 1, 2, 3 all the way across. So that's how we got that, because we need to fit our data. We'll just go ahead and count by ones for the absences. Now for test scores can really range from a 0% to 100%. In our case, it looks like our smallest test score, let's see, was the 65, and our highest test score is the 97 up here. That's a little bit cut off on your screen. Okay, but I'm going to go ahead and just call it 0 to 100. And since there's 10 grid lines, let's count by tens. All right. So on this one, 0, 97. Again, I like to cross them off as you go. Just don't cover them up in case you need them. So there's 0, 97, 388, 293, 583, 773. I'm going to go back and make this one rounder. 970, what do you write on the corner here? 588, 194, 965, 873. Okay, so that's our data. Overall, when we make a line of fit, so we've already talked about outliers, gaps, and clusters. I would say this has no outliers. It has no gaps and really no clusters either. But our data is kind of following a trend where as we go to the right, as students have more absences, their final exam score is going down. So that data relationships we talked about yesterday, where it's positive, negative, or no relationship, this definitely has a negative relationship. As the absences are increasing, our final exam is decreasing our score, which should make sense. The more you miss school, the less you're learning. So give me 1 second. I'm going to see if I can pull up a ruler here. Okay, so you want to take a ruler, or in our case, a straight edge. If you need a note card, let me know. You can grab one. But we want to take this ruler or straight edge, whatever you have. We were using note cards this year because it's easy for you to carry around. All right, sorry about that. I figured it out. So my goal with this straight edge is to try to get about half my points above and half my points below. And that's why our lines of good fit are not always perfect as humans, because there's room for human error. But roughly, I wanted to go through the center of my data with about half of my points below and about half above. So I would say around there is good. And then you would just draw your line with your straight edge through those points. So I'm going to get rid of this ruler here. Okay, so there's my line of fit. Now to write the equation for this line of fit, it looks like I would roughly be up here. I would even say it's 0.99. I'm not quite at 100. So I'm going to use the point 0.99 for my intercept. And then the other point it looks like it's going right through here is 580. So I'm going to do that next, 580. And then to find my slope, I'm going to subtract. Okay, 99 minus 80 is 19. And 0 minus 5 is negative 5. This slope wouldn't simplify, so here's my slope. And then my intercept is 99. So my equation would be y equals negative 19/5 x plus 99. And that would be my line of good fit that I estimated. And then we could use this equation to make predictions. Like if they wanted to know, let's say, what would a score be of a student with 6 absences? Because 6 isn't one of our data points here. I could replace x with 6. And I could solve for what that would be. So let's go ahead and do that. So 19/5 times 6 plus 99. And you can type that into your calculator. In fact, I'll pull one up and show you how to do that as well. All right, so our slope was negative 19/5. So fraction button here. You can see the buttons I'm pushing up here. Negative 19/5 times 6. And then plus 99, we would say a student with 6 absences. And when it gives you the fraction, to get the decimal, you can click the toggle button right above enter. And that switches back and forth between a fraction and decimal or vice versa. So we would expect them to get approximately a 76.2%. Okay, and then this could also go the other way. Like if they wanted to know how many absences did a student with 100% get, we could plug in 100 for y and solve for x. So it does go both ways. Most often we will ask you to plug in an x because it's a little bit simpler. But because you know how to solve equations, they could also ask you to plug in for y. All right, so there's example 1 for today. We're going to do one more. So this time we have year and attendance, okay? So it looks like we're just going 1 through 8, and remember we have 10 grid lines in the background here, so let's count by ones again. I'm going to label my x-axis year. So we'll do 1, 2, 3, all the way across. 9, 10. And then let's look at attendance. So it looks like we need to go from 420 up to 2,400 in total. So if I have 10 grid lines, let's go ahead and round this up to an even 2,500. And we'll count by 25s, or 250. Like if I have 2,500 and I need to take that into 10 grid lines, that give me 250. So we're going to count by 250s instead of ones here. 250, 500, all the way up. And I believe this is filled out for you again. So just give me a moment to catch up. And then just to give this some context here, I believe this is like when someone would start an event, like let's say even the Han John, and then the amount of people that would show up to that event. So the more years it's going on, the more people are attending. So just to give you some context there, I believe that's what we're talking about. Okay, so my axes are labeled now, and I just need to plot my points so that I can draw my line. And then ultimately we want an equation for that line. So 420, you're gonna have to kind of estimate where some of these would go. 2 500 will be right on the grid line. And again, I'm going to mark them off as I go. 3 650, 4 900, 5 1100. Oops. It's supposed to just be a check mark. 6 1500. That's going to be right on a grid line again. 7 1700 or 1750. So right on a grid line again. And 8 2400. Okay, so again, this one doesn't really have any clusters. I wouldn't say any major gaps, any major outliers if we're talking about that, but it does have a positive relationship overall from left to right. As the years went on, the more years they put on this event, the more people attended the event. So let's pull out that ruler again. And my goal with this ruler is to try to get about half my points above and about half below, because this is not, the points I have are not a perfectly straight line, but I want to try to use a line to model what's going on so that I can make predictions in the future. So I'd say roughly this is a good place for us to be at. So I'm going to go ahead and draw my line from there and get rid of this ruler. Okay. So I would say it's actually in the corner here at 0 0 for our intercept, but you should always pick one of your points to be your intercept since you need your intercept anyway. And then it looks like we're going right through 6 1500 here. And I'm going to go ahead and subtract this way. 1500 minus 0 is 1500. 6 minus 0 is 6. And then let's see if that divides in evenly. It might. 1500 divided by 6 is 250. So our slope is 250. And then our intercept is 0. So we would have y equals 250x. You could put the plus 0 if you wanted. You don't have to. Okay, and then if they would say, what do you predict the attendance to be like in year 20? You could take 250 times 20 to get that attendance. Or if they wanted to know, what year do you expect to hit 3,000 attendees? You could plug in 3,000 for y and then divide by 250 to find x. So that's why we like lines of fit. We're working on lines of good fit today. You have a worksheet next, and we'll talk about lines of best fit with the computer tomorrow.